Hello and welcome to the first part of the video here, explaining how to do video analysis with PhysMo for our labs. This file here is the video we want to analyze. I'm going to go into the distro. I'm working under Windows, so the run physmowin.bat is the file I want. It runs the batch file that launches the software. It's just picking our working directories here. There we go. There's our title card. We're going to open the video. And if we go again to the desktop, okay, this is faster here. Video analysis, that's where I save the video. We're going to create a directory to work in. It will fill this directory with a whole bunch of videos. Just going to make it a new folder. It's the demo car analysis. Okay. Yes, that's allowed. Okay. Now we will open it. So now that it's decomposing the video, this is the part where it's going to be breaking things down frame by frame. What matters for us is that it gets the job done. So we just have to wait a little bit while it decomposes. I'll pause the recording while that happens. All right, we can unpause now. So this is what happens after it loads. Now notice here we can actually fairly clearly see our meter stick. With this resolution, we've got the whole thing here. It's not as straight as we would like. I probably should have tried to at least align it with the tiles. I wasn't able to do the Hot Wheels because, as you could probably imagine, it's a little too tricky to try and release the car properly and videotape it myself when I couldn't prop up the phone. So up here we have options for what we want to do. We don't need to find the angle just yet here. We can set our origin. We can calibrate. We're going to calibrate first. I'm going to zoom in. So this is 3 times zoom. So that's one end of the ruler. That red mark covers one of them. Come down to this end. That red mark covers the other. I'm going to set the distance to 1 meter because it's 2 ends of the meter stick. We've set our calibration. So now, if we scroll back up to where the car is, just going to measure the car's speed as we're going along here. If we watch the upper left, if I just play the recording, see it's about 3 seconds where I push the car, goes at a horrible angle, comes out the other side. So I play it again. I'm going to pause. Now, I'm going to back up frame by frame. Get a nice clear picture of the car here. Now, I'm going to set my origin. I'm going to pick it here. So that becomes the 0, mark. And I'm going to plot. There's the front of the car. One more frame. Front of the car. One more frame. Front of the car. And I'm going to keep doing this frame by frame. It's getting a little bit blurry. We will do this with every frame until the motion is complete. Pausing again, so we don't have as much tediousness in this video. Unpausing now, we're close to the end. So we're got the video all the way over. I'm just going to trace it until the end of the car goes past the end of the meter stick. Obviously, this is not going to be a great quality data run. There we go. We are now out of frame. So that's the portion that we have. And we can see with our X's and Y's, it's converted these pixels into meters. And I'm going to export the data. Call it demo car analysis again. And we will save. So the key now here, we have it in our documents. It was that demo car analysis. But if I go home, no, it's still recording these. So documents, demo car analysis. So it pulled out each of these frames. It will take up a bit of drive space. Specifically, if I go properties with these, we could find how much drive space. But once we've done the lab, we don't need the individual frames. There's 187 megabytes here. What we need is the Excel file, which is opening now. So for starters, we don't need any of these columns where we didn't actually click to calibrate. We can delete all of our columns. We don't have any comments, but what we want to do is take a look at, say, Vx in meters per second, our vertical velocity in meters per second, and our total velocity in meters per second. It's one of the analyses that we're going to be doing in our lab. So if we really want a good secant line, here we will want to take our slope, which is y2 minus y1, taking the point before and the point after to get the best average at that space, divided by x2 minus x1. These are times. Now we're going to want to do this for the Vx and the Vy. So when it comes to the time, I'm going to put the dollar sign in front of the B for absolute referencing. Now I can highlight all of these. So it's actually taking our y velocity. We can see there's a few places where the y doesn't seem to change. Most of our velocity is horizontal, which is, exactly what we are looking for. Just to be sure, we want to add these up as our vectors. So we want to take the square root of x squared plus y squared. And we'll fill these down. Now we have speed. We can see here, my finger hadn't quite cleared it. It seems to be picking up speed. It peaked around this point, and now it's trailing off. So if we say our mass, let's call it 200 grams for 0.2 kilograms as an average. Really should have measured that properly, but this time I'm going to actually do the mass or the energy in joules. Our kinetic energy is 1/2. Now we want the dollar signs before the L and the number because we don't want to change the row or column. We want to use that one every single time. Times V squared. That appears to be confusing it. So I'm not sure why we have some. Oh, it's because I actually put the units in the cell. That is not a number. We'll put the kilograms here. And then we will increase how many decimal places we display. So now this is our kinetic energy in joules. So we add a little bit to it. Peaks at about 0.14 joules, and it slowly bleeds off. Right around here, I'm betting if you go back to the video, would be where it actually seemed to collide wholesale with the side of the ruler. But that gives us some understanding of how we do our analysis. So when we're looking for our speeds at any given time, we want to take the secant lines. If we really want to be precise, We can take 2 or 3 in a row that we have confidence in. They are similar. Something like these, right around that point. And do the average of those, which Excel provides for you down here. Excel now does the sum, the count, and the average together if you're doing it in Google Sheets. By default, it shows the sum, but you click on the sum and it'll pop up with 3 options. But this is how we do it. That's how we calibrate the software. That's how we use the software, how we export it, import it into Excel, and then take our positions and turn them into speeds, not technically velocities on this final one, because we don't have the direction incorporated, although we could do that if we felt like it.